We are familiar with the triangle and classification of triangles on the basis of sides and on the basis of angles. In addition to the properties of triangles that we have already studied, there are some more properties related to areas of triangles. Let's discuss them. Recall that the general formula for calculating the area of a triangle is half the product of its base and height. Consider two triangles, triangle ABC and triangle PQR, as shown. We know that the altitude AL of triangle ABC is the height of the triangle ABC. Likewise, an altitude PS of triangle PQR is height of the triangle PQR. Thus, we can write the area of each of these triangles as shown. Now, label the obtained areas as equation 1 and equation 2. Let us find the ratio of the area of triangle ABC to the area of triangle PQR. What is the conclusion that we can make regarding the ratio of the areas of triangles? Note that BC and QR are base lengths of the triangle ABC and triangle PQR respectively. AL and PS are heights of the triangle ABC and triangle PQR respectively. This result can be generalized for any two triangles, triangle 1 and triangle 2, with respective bases as B1 and B2 and the corresponding heights as H1 and H2. Let's use this property to find the ratios of areas of two triangles with common base, with same height, and also with common or equal bases and equal heights. First, consider triangles. Triangle PQS and triangle QRS on common base QS as shown. Note that triangle PQS has height PS and base QS. In triangle QRS, draw a perpendicular RT such that it has height RT and base QS as shown. Now, use the property of ratios of areas of two triangles. We get the ratio of the area of triangle PQS and triangle QRS with the same base QS equals to the ratio of their corresponding heights. In general, we can say that the ratio of the areas of two triangles with same base is equal to the ratio of their corresponding heights as shown. Now, if two triangles ABC and triangle ACE have the same height AD, then what can we conclude about the ratio of the areas of the triangle? Now use the property of ratios of areas of two triangles. We get the ratio of area of triangle ABC and triangle ACE with the same height AD is equal to the ratio of their corresponding bases. Therefore, we can say that the ratio of the areas of two triangles with same height is equal to the ratio of their corresponding bases as shown. If triangle ABC and triangle DBC with the common base BC are between the same parallels AD and BC, then what can we conclude about the ratio of the areas of the triangles? Note that the triangle ABC and triangle DBC have the common base BC. The distance between parallel lines is constant. So are the heights of the two triangles. Now use the property of ratios of areas of two triangles. We get the area of triangle ABC equals to the area of triangle DBC. Therefore, we can say that the triangles with common or equal bases and equal heights are equal in areas. All the properties can be summarized as shown. Let's solve some problems based on these properties.